All right, so congruent figures. The word congruent, you want to think of it similar to the word equals, but we cannot say that two figures or two shapes are equal because we use the word equal when we're talking more about values and numbers and variables. So when you're talking about figures and shapes, we use the word congruent. So it doesn't make sense to say that two shapes are equal because shapes don't have value. So instead we're going to say that congruent figures. And when we talk about congruent figures, it means that they have the same size and shape, which makes them look equal. So again, the word congruent with geometry is the same thing as equal in algebra. I'm going to draw some triangles. Try to make them as congruent as possible. This one looks a little longer, but we're going to assume that they're congruent. And we'll just say that triangle ABC is congruent to triangle XYZ. Okay, now I know I just drew these freehand, but I'm making a statement and I want you to assume that the triangles are congruent, meaning they have the same size and shape. Now, if that's true, then there are some important facts that we can get from this. Now, the way it's worded is very important and the way the notation is given. So if I say that angle A corresponds to angle X, that means it's in the same position and it's the exact same size in each triangle. And you notice that because I see A is listed first, X is listed first. So sometimes, even if you don't even have a picture of what the shapes look like, you can cover it up. And just from what's given, you can get a lot of information from that. You can conclude that angle A and angle X are corresponding. Angle B and angle Y, no matter where they are corresponding. And wherever angle C is, it's going to be corresponding to angle Z. Also, segments. When you connect the point A and B together, that segment is going to be exactly the same or corresponding to XY. Those 2 points connected together will make a segment. And these 2 segments will be corresponding. So it's like saying matching. So corresponding is almost like matching angles. So I can also say that angle B corresponds to angle Y. And we identify them with different lines. And I can say that angle C with 3 lines corresponds to angle Z with 3 lines. So again, I don't really need to look at the picture because we could already tell. C and Z are listed third. So that's going to be those corresponding angles. If you notice B is in the middle, Y is in the middle. Those are corresponding angles. That's how you can identify them also, just by the notation that you're given. So another thing is the angle side. So let's say angle AB. Since it's the first 2 letters, without even looking at the picture, I can conclude that it must be XY are corresponding sides. Okay, so we can say that these are corresponding sides and the insides are the corresponding angles. And again, angle AC, if I go from the first one to the last one, AC must be exactly corresponding to XZ. And if we do that, it is AC, XZ. Again, just by the positioning of the notation that you're given. So again, if you don't have an image, you can always know that A, C, X, Z are corresponding. Even if they give you B, C, that would correspond to Y, Z. The last two. So it's not like they just randomly listed them in any order. The order is very important. So keep that in mind. So let's look at an example of how we use congruent figures and what we can do with that and all this notation. The first example. Let's name some corresponding angles and sides. So let's say I have a trapezoid. Two trapezoids. And just to see that we understand all of this labeling and how it goes, what are some corresponding angles and corresponding sides? All right, so some corresponding angles. In this drawing, some corresponding angles would be angle A, angle W, this is angle A and angle W. That symbol, I just put a line through it so it looks like the angle, so it doesn't look like a less than sign or a L. It's up to you, it depends on how you want to write it. Angle C corresponds to angle Y, or I just go in order. Angle B next, and angle X are corresponding angles. Angle C and angle Y are corresponding angles. Angle D and angle Z are corresponding angles. Now, right now, it's very easy, right? Because you just look straight across and you match them. So pretty much it's like you're matching them. But if this trapezoid were upside down or it was laying on its side, you really would have had to pay more close attention to where the location and the position in relation to the other sides so you can find the corresponding or matching angles. And that's when, if they are labeled correctly, it would be easier to see. So this would be trapezoid A, B, C, A, B, C, no, A, B, D, C. And they would say trapezoid A, so that's W, X, Z, Y. It's got to be listed in the order in which you draw it. So A, B, D, C, A, B, D, C corresponds to trapezoid W, X, Z, Y. So then that way we would have just matched. A goes with W, B must be with Z, D must be with Z, and C must be with Y, without having to look at it being flipped or upside down. So it's important to note if they're giving you the labels of the shape, then you can just look at the notation that's given. All right, corresponding angles. No, I'm sorry, corresponding sides. So AB and AB, WX. Then we have BD corresponds to XZ. Again, if they're giving you the notation, the label of the triangle with notation form without an image, I would just say BD, WZX. Then I do AB, WX, then I would go to BD, XZ, then I would go to DC. The last two would correspond to ZY. So DC, ZY. And the last one would be AC. So if I go from the first one to the last one, labeled. And here I go from the first one labeled to the last one labeled. WY. And then we can double check it in the image. ACWY. So there you go. So again, the easy part is knowing what matches with what. The difficult part, again, would be when this is on its side, when it's upside down, or it's out of order, then you would have to depend on the labeling of the figure. Is a lot easier, in my opinion, to be able to come up with what's corresponding to what when everything looks like it's mixed up, turned upside down, and confusing. All right, example 2. Now, how do you draw two congruent figures? If you're going to prove to me that they're congruent, and to do this, all you have to do is 2 things. Make sure that your shapes are the same size and shape. So 2 figures that are the same size and shape will be congruent. I'm choosing 2 rectangles. They have to be different. You know, I need to start A, B, C, D, but anyway. E, F, G, H. So I chose 2 rectangles. I'm making them look congruent, but to be for sure and make it definite, I would just have to label the sides. 2, 3, 2, 3. Now it shows there are 2 different rectangles and they have the same size, same shape, which means they have corresponding angles. All 4 of them are 90 degrees. They correspond and they're the same size. And all of their corresponding sides are also the same. So that's one thing we need to keep in mind, is it's important to note. So let's make a note of that. Two figures are congruent, which means exactly the same size and shape, if their corresponding angles and sides are congruent. So I have corresponding angles that are congruent, same measurement, and I have corresponding sides that are also congruent, and corresponding sides again that are congruent. So therefore, my entire figures are congruent. Now, just so we can get used to how we're labeling these, I would have said rectangle A, B, it's in the pattern in which you would draw it. A, B, D, C, I should have did it the other way around, is congruent to rectangle E, F, H, G. Doesn't have to be in alphabetical order, it has to be in drawing order. So the order in which you would draw this rectangle, again, you can't go A, B, C, D because you have a line crossing through the figure. So it's always best to just go around the perimeter of the figure as you're labeling. All right, and one last example. Another marker. How do we use congruent figures? And knowing two figures are congruent is helpful when you have a missing side. So, for example, say I have two triangles. And I'm saying A, B, C, and X, Y, Z. This is 3, 4, 5. And let's say I want to know how long this is. So, assuming that triangle A, B, C is congruent to triangle X, Y, Z, we want to do A. Find the segment YZ. How long is that segment YZ? How long do you think this is going to be? If I'm telling you that these two triangles are congruent, what can you tell me about segment YZ? Well, two ways you can look at this. YZ are the last two letters that corresponds to BC, the last two letters. So in my figure, YZ corresponds to BC. Since we know that segment BC is congruent to YZ, because they already told us that they're congruent figures, and we know that this is measured as 5, so we can say that YZ is equal to 5. So segment YZ is 5. And that's how you would use congruent figures. You would use what you know is congruent and just match the length on the other leg that's missing. So let's say if we want to find the perimeter. Of triangle XYZ. Well, if all of their side lengths are congruent, because the two figures are already congruent, then I have 3 pairs of corresponding sides that are congruent. So AB matches and corresponds to XY, BC corresponds to YZ, and AC corresponds to XZ. So all those 3 are going to be the same measurements over here. So all you're going to have to do is find the perimeter of triangle ABC, which would be 3 plus 4 plus 5. That's going to be 12. Yes. And since we know that they are congruent figures, we can conclude that triangle XYZ has a perimeter equal to 12 also. Just because we know the matching sides are congruent, all of the triangle is congruent, so we can just do that. Another way you could have done this was to just label what you know are the corresponding sides and then conclude that it's going to have the same perimeter. And there you go. Again, corresponding angles, corresponding sides means you have corresponding figures. There you go. Really quick, I just wanted to make sure that we understand what the corresponding means. You can just think of the word corresponding, right, maybe somewhere at the top of your notes. It's synonymous to the word matching. And I'll put an arrow. So whenever you hear me say the word corresponding angles, I'm thinking you could think of matching angles. If I'm saying corresponding sides, the matching sides. So that would make it easier to understand.